Hi everyone, and thanks so much for joining us. CloudVision builds on top of the foundation of EOS to provide a platform for network-wide workload orchestration and workflow automation. Today, I'll be going through a demo of some of the major features that we're shipping with CloudVision. By leveraging the state-centric architecture and synchronization mechanism of EOS, we're able to build a network-wide database, aggregating the network state from the sysdbs on each switch. This network-wide database then becomes a single point of integration northbound to cloud orchestration systems, overlay controllers, and other network services. It is also our point of integration with information available on arista.com, providing updates on releases, pcerts, and newly found escapes. In this demo, I'm going to walk through how CloudVision automates the provisioning of VXLAN-based tenant networks in both the VMware NSX and OpenStack environment. We'll also show you how the CloudVision portal provides a turnkey solution for automating the end-to-end network provisioning process. NSX integrates with CloudVision via the CloudVision Exchange. NSX enables users to configure logical tenant networks using VXLANs from the UI, enabling L2 mobility of workloads across an L3 fabric. However, not all infrastructure is virtualized, and so you need a way to map physical infrastructure, like servers, storage, or firewalls, into the tenant networks defined by VMware. This is accomplished by integrating NSX with CloudVision via OVSDB, an open standard for integrating hardware VTEPs into virtual environments. NSX is responsible for managing all of the virtual VTEPs. It knows the configuration of each virtual VTEP and which MAC addresses are behind those virtual VTEPs. You can see here that we have a compute node along with a service node managed by NSX. CloudVision is then registered with NSX as a gateway VTEP. CloudVision tells NSX about all the physical switches it manages and their configuration, and you can see all of the interfaces available at NSX below. One important aspect of the integration is that we also provide this information from a single place in the CloudVision CLI. This is a piece that is often overlooked in how SDN controllers integrate with the physical infrastructure, and it empowers the physical networking team with the visibility and control they need to manage and debug the underlying infrastructure, even as virtual resources and configuration managed by NSX may be changing. You can see here that we've mapped VNI 10,000 to VLAN 10 on interface Ethernet 14 of bleaf 3. This is based on configuration entered by the user at NSX and then provided to CloudVision via OVSDB. NSX manages all of the MAC addresses learned behind virtual VTEPs and provides that information to CloudVision over OVSDB. Similarly, CloudVision provides all the reachability information for all the devices it knows about behind physical VTEPs and provides that to NSX. In doing so, both NSX and CloudVision are able to build a full view of the VXLAN L2 database for each VNI. In addition to abstracting the details of the physical network from NSX, CloudVision provides this information from a single point to the physical networking team, enabling them to manage their networks end-to-end across their infrastructure. Now, in an OpenStack environment, CloudVision similarly provides an integration point to the physical network for Neutron, enabling the provisioning of tenant networks across both virtual and physical infrastructure. In this setup, we have a 2-rack OpenStack cluster with an L3 fabric in between. We're going to spin up one VM in each rack and get connectivity between them by automatically provisioning the appropriate VLAN on each top-of-rack switch port, and then automatically mapping that port plus VLAN into a VNI across the L3 fabric. Now, if we go into Horizon, we can create a new network and assign it a subnet. Now that we've created a network, we'll go and spin up 2 VMs. While we do that, let's talk a little bit about what's going on under the covers. CloudVision learns all of the information about the tenant networks, the VMs within them, and what compute nodes those VMs have been placed on from our ML2 mechanism driver. This enables it to build a full view of the tenant network topology. CloudVision similarly learns the full physical topology from all the switches. By overlaying the logical tenant network topology on top of this physical topology, CloudVision is able to appropriately provision tenant networks across the physical infrastructure, while also giving the physical networking team full visibility into the applications managed by OpenStack that are being run on top of it. Now let's go and take a look at the network topology provided by Horizon. And you can see the tenant network along with the 2 VMs that we've placed within it. If we launch a console on one of the VMs, we can see that we have connectivity between it and the other VM we've launched, even though they're separated by an L3 fabric. From the CloudVision CLI, you can see which networks have been created within OpenStack, the VLANs that Neutron assigned to them, and the VNIs that we've then mapped them to over the L3 fabric. You can similarly use the CloudVision CLI to locate VMs within the physical topology. In many organizations, the compute and networking teams are separate and use different tools. So CloudVision enables instantaneous automation for the compute team while giving the networking team visibility and control. Through its integration with orchestration systems and overlay controllers, CloudVision provides an end-to-end provisioning of and visibility into VXLAN networks. However, managing a large-scale cloud network requires much more than simply configuring overlays. The CloudVision portal provides a single pane of glass for provisioning and monitoring the underlying physical network in a fully automated manner. On the home page, you'll see the various apps available to the user. On the right, the Arista.com newsfeed provides updates on new releases, field notices, and security advisories. In this demo, we're going to go through the network provisioning feature of the CloudVision portal. Devices are arranged into logical containers. You'll see here that we've created containers for 2 different data centers, as well as for the pods within each data center, and the availability zones within each pod. The undefined container contains all devices that have yet to be configured. These are devices that have booted up in zero-touch provisioning mode, have registered themselves with the CloudVision portal, and are waiting for the user to define their configuration. Rather than dealing with configuration as one big monolithic file, we allow you to break up configuration into configlets that can then be applied based on the properties you want to enforce. So, for example, you can apply a AAA configlet at the top tenant level to ensure that all devices being managed by a given CloudVision portal instance use the same authentication credentials. This model reduces config duplication and enables you to ensure that all devices are given the correct configuration based on where they're deployed in your network. Devices are automatically assigned labels based on certain properties and can also be assigned custom labels by the user. This allows you to filter down your view based on the criteria you're interested in. For example, finding all devices that are top-of-rack switches in Data Center 1, Pod 1. In addition to the list view, devices can also be viewed in their logical topology hierarchy, and we can similarly do filters and searches from there. Now, what I'd like to do for this demo is walk through a common use case for networking teams, applying or updating a security ACL across all devices in a given data center pod. If I go to the configlets page, you can see the server port ACL that I've created. Configlets are simply subsections of config and can be validated against devices before being applied. Now, if I go back to the network provisioning page, I want to ensure that all devices within Data Center 1, Pod 1 have this configuration. So I go ahead and apply this configlet at the container level. Note that while I've saved this change, nothing has actually been done to any of the devices. Under the covers, we're leveraging eAPI, our JSON-based API, as well as config sessions at the CLI, in order to apply these changes and test them out without actually having them take effect on the device. If I choose one device here, I can see that there's a pending task, as well as view what the current versus design configuration looks like. Here I can see that my server port ACL has yet to be applied. The model is that all actions done by the CloudVision portal must be explicitly approved. I can go to the task management page, see the pending tasks, and then run them one at a time or in parallel based on when I'd like to actually apply them across my network. All of the actions available at the UI are also exposed via JSON APIs. This means that you can easily integrate the CloudVision portal with your existing task management and approval system. For example, you can automatically create requests within ServiceNow for every task that is created within CloudVision, and then only run that task once it has been approved and scheduled via ServiceNow. Or if you have your own config management database already, you can integrate that into CloudVision for defining configlets and how they're assigned to devices, but leverage CloudVision to automate how those changes are applied across the network. Speaking for the Arista engineering team, we're really excited for the launch of CloudVision and look forward to working with you to integrate CloudVision into your environment.